So the first fundamental trig identity that we're doing, here's the proof that we're not going through in class. As I said, you can view this if you want to see how it works or if we're going to need it later. And it says that sine theta over cos theta is the same as tan theta. So we're just going to see why does that always work. It's just going to be something you're going to remember and we're going to use quite often. So let's look at why that's the case. Okay, we're going to need our cast diagram or our Cartesian plane with x, y to see why this works. So if we look at a point, now this point can be anywhere, but I'm going to draw it in the first quadrant just because it's easier to work with. So if we've got a point there, and we normally say there's point P, X, Y, so we formed our triangle, and it gave us an angle of theta from the positive x-axis. Then the reason I like to draw this in the first quadrant is just so we can look at it as a straight up triangle and remind ourselves, oh, well, that distance there is x, that distance there is y, and we call this r, the radius, because we could draw this as a circle going round. Okay, and then let's look at each side of this equation. I'm going to start with the right hand side to say tan theta. What is tan theta in terms of x, y, and r? Well, in terms of opposite, adjacent, hypotenuse, we know from that SOHCAHTOA that tan is just opposite over adjacent. So it's y over x, which you can see from this. And I must say I was interested by my grade 10s who, when I asked them how do they remember it, most said they just remembered. They've used it enough now that they go tan theta is y over x, but you can always draw a quick sketch of a diagram to remember. Okay, so that's our right hand side. Let's look at our left hand side. We've got sine theta over cos theta. Now that's just the same as sine theta divided by cos theta. That's what the fraction means. And we're doing that because it's going to be easier when we've got our fraction, because sine theta, well, it's opposite over hypotenuse, or you might just remember, oh, well, that's just y over r. Divided by cos theta, well, you might just remember cos theta is x over r, or it's adjacent over hypotenuse, so it's x over r. Okay, let's do our tip and times, or keep, flip, switch, change, KFC, whichever way you remember. The point is, we know that to change division, we can just change it to multiplication. So it's y over r times r over x. And if we need to simplify that, well, we know that we can kind of cross-cancel these. So r goes in there once and goes in there once. So y times 1 is y. 1 times x is x. Y over x, hey look, these are the same. Y over x is our left-hand side, and y over x is also our right-hand side. And there we go. That means that those two must be equal. So there's our proof for the first one. And the second one's very similar. So let's run through it here as well. So our second trig identity, fundamental trig identity, says that sine squared theta plus cos squared theta equals 1. Always going to be the case. And as I said in the lesson, it's just going to be something that you remember. Sine squared plus cos squared equals 1. Of course, that's sine squared theta plus cos squared theta equals 1. So what does this mean again? This means sine theta all squared. And cos squared theta is just a short way of saying cos theta squared. So let's just look at our left-hand side and see if we can manipulate it and get it equal to 1. And this is what we're going to be doing in this section, is very much proving these identities, not just the fundamental ones, but given anything, and we're going to prove them. So sine theta, well, maybe you remember sine is just y over r, so that's squared, plus cos theta, well, that's x over r squared. And we've got the diagram up here if we needed to remember y, and it works in any quadrant. I've just drawn in the first quadrant because it's easier to see. Okay, so that's y squared over r squared plus x squared over r squared, because the squared just happens to numerator and denominator. Well, our denominators are the same. So let's start saying these are equal, this is equal. So r squared as our denominator, so on top we just have y squared plus x squared. Well, y squared plus x squared, so that's over r squared. Well, x squared plus y squared, let's look at it from Pythagoras. X squared plus y squared equals r squared. X squared plus y squared equals r squared. Pythagoras, that side squared plus that side squared equals that side squared. It's also how we define the circle. So if that's the case, x squared plus y squared equals r squared. Y squared plus x squared is just r squared. What's anything divided by itself? 1. So in other words, the left-hand side we've just shown is 1. Hey, so that's the right-hand side. So we've shown that the left-hand side equals the right-hand side. And I'm just going to put this x squared plus y squared equals r squared. And I'm going to go think Pythagoras, just so it's here for reference as well. And there are proofs of those trig identities, so you can go through that, but we're just really going to use them. We're going to use that very often, and we're going to use this very often to prove things.